D block chemistry. Look, if you're serious about getting a top rank in CUET, you know these questions are coming. So today, we're not just going to study it. Oh no, we are going to crack the code so you can guarantee you get those marks.
So let me ask you this. What's the #1 reason students, even the really smart ones, lose marks in D block chemistry? Just think about it for a second. Is it what you'd expect?
I'll tell you what it's not. It is not about trying to brute force memorize every single property of every single element. We've all been there, right? It's slow, it's painful, and it is absolutely not the strategy that lands you in a top college.
The real secret? It's about spotting the patterns and then hunting down the exceptions. You see, there are a few key culprits that consistently pop up on the exam, and they're designed to catch you off guard. By the end of our time here, you're going to know exactly who they are and how to beat them at their own game. So here's our game plan. We're going to master this whole topic with 3 simple keys. First, we'll solve the oxidation state puzzle. Then, I'll give you the magnetism shortcut. And finally, we'll crack the color code secret. Let's dive in. All right, first up, the oxidation state puzzle. This is really where the D block elements start to show their tricky personality and why they don't like to play by the normal rules.
You know, you're probably pretty comfortable with the S and P block elements. They're predictable, right? Their oxidation states are usually fixed. But the D block elements? Phew, they're a whole different story. They're tricky. They can have a huge range of oxidation states, which makes them complex, but also a goldmine for the people setting your exam.
So, why? What's the secret? It all comes down to this one little fact right here. The energy gap between their outer N's electrons and their inner N-1 D electrons is incredibly small. That means they can lose electrons from either shell, or sometimes both. And that's the key to their wild, unpredictable nature.
And this just shows it perfectly. Take a look at iron. You've definitely seen it as both +2 and +3. But then you've got manganese. I mean, this one is the superstar of variability. It shows every single oxidation state from +2 all the way up to a whopping +7. It's this range you got to get comfortable with.
Okay, but listen up, because here is a massive, massive trap. Zinc. While all its neighbors are showing off their different states, zinc just stubbornly shows a +2 state. Only +2. So why? Because losing those 2 electrons gives it a completely full and super stable D10 configuration. The exam setters know students forget this one. Don't let that be you.
All right, quick reset. That was the core theory. Now let's turn that knowledge into actual marks. This next key is all about speed and accuracy when you're staring down a numerical problem in the exam hall.
Say hello to your new best friend from magnetism questions, the spin-only formula. Now I know it might look a little intense, but trust me, it's just a simple plug-and-play shortcut. That little n is just the number of unpaired electrons. Find n, plug it in, and boom, you've got the magnetic moment in seconds. This is pure marks, right here for the taking.
Okay, let's hit pause for a second. A quick pause and think moment. Before we even touch that formula, what does it mean if something is diamagnetic? It means it's repelled by a magnet. So, what does that tell you about its electrons? Go on, think about it. Got it? It means all of its electrons are paired up. There are 0 unpaired electrons.
Ready to test that? Let's do a quick-fire mini MCQ challenge. Which one of these ions is diamagnetic? Is it A, B, C, or D? Remember, you're hunting for the one that has 0 unpaired electrons. And the answer is C, titanium 4+. But why? Well, to become Ti4+, it has to lose all 4 of its outer electrons. That leaves it with a totally empty d orbital, a d0 configuration. No unpaired electrons means it's diamagnetic. So the big takeaway here, a d0 configuration means diamagnetic. Easy. Okay, let's move on to our final key, the color code secret. This is another classic property of D block elements. And guess what? Just like everything else, it all comes down to those d electrons. Here it is. The golden rule you just have to remember. If an ion has a partially filled d orbital, it is almost always going to be colored. Why? Because the electrons can literally jump between the d orbitals. When they do that, they absorb some light and reflect the color that we see. It's called a d-d transition. And of course, right after the rule comes the trap. If that d orbital is completely empty, like d0, or completely full, like d10, well, there's no room for those electrons to jump around. No d-d transition means no color. These ions are colorless. It's as simple as that. Okay, time for another pause and think. Let's connect the dots here.
We just said that D0 and D10 ions are colorless. Now, based on what we just learned about magnetism, which ions have those D0 or D10 configurations? Think back to our little quiz. Yep, they're the same ions that were diamagnetic. You see how it's all connected?
Okay, second attention reset. This is where we put it all together. It's time to unmask those culprits I promised you at the beginning. I want you to stop thinking like a student for just a moment and start thinking like the person who writes your exam paper. And here they are. These are your primary targets: titanium-4, copper-1, and zinc-2. Just look at the pattern. Titanium-4+ is D0. Copper+ and zinc-2+ are both D10. And because their d orbitals are either totally empty or totally full, they are both colorless and diamagnetic. This one little table connects everything we've just talked about. You master these three, you've mastered the exceptions.
So, let's bring this all home. Time for a final score booster just to make sure this knowledge is locked in tight.
I really want you to burn this idea into your brain. Anyone can learn the general rules, but top rankers, they're the ones who have mastered the exceptions. That is the difference between a good score and a truly great one.
Okay, let's lock this in. Quickfire recap. 1. Oxidation states are variable because the ns and d orbitals are super close in energy. 2. Magnetism is all about those unpaired electrons. Use the formula. 3. Color comes from electrons jumping around in partially filled d orbitals. And 4, the most important one, the culprits, those D0 and D10 ions are always colorless and diamagnetic. That is the master key.
You've got the framework now. You know what to look for. The next step is to take this way of thinking and apply it across the entire D block. So, are you ready to go beyond just knowing the rules and start to truly master the why? Go get those marks.